Alright, so let's simplify the following. So the first thing is looking at the laws of logs. What can we do here? The first thing we can do is recognize that log 9, or I should just say 9, is the same as 3 squared. Once you recognize that, right, we should remember the rule that allows us to do it. Take the power and bring it down to the front. So we're going to do that. All right, so we're going to take the power, leave just 3, and put the power at the front. Now we have 2 log 3 over log 3. You should see that log 3 here cancels log 3 here, which leaves us with just 2. Right, so this one is 2. Now the calculator would also give you 2, but we wanted to practice using the rules. Alright, so let's look at another one. Log 125 over log 5. Now similarly, log 125 is 5 to the third power. And we are going to do what we just did. We're going to take that power and bring it down to the front. And that gives us 3 log 5. Right, so what I just did, I took the power 3 and moved it down to the front of the class. Yeah, so we have 3 log 5. Log 5 cancels log 5, leaving us with our answer to be 3. Alright, so we're just using the laws of logs. Now this one we did in class, but let me run it through again. So the first thing is noting that we have a quadratic function which can be factorized, x squared minus 1. And you should also see that this is difference of 2 squares. Right, so once you can see that that is difference of 2 squares, then the next step should kind of jump out at us. Right, so this will be log x plus 1 times x minus 1. Right, so x squared minus 1, we express it as x plus 1, x minus 1. And then it's a subtraction. Right, so one log minus another log, both of them are base 10, same base. So we can combine, and when we have a subtraction, we divide. So we are going to have here we go, log right, so in the numerator it's going to be x plus 1. In the denominator it's going to be x plus 1 times x minus 1. At this point we should be able to see that we can cancel. Alright, we have x plus 1 here, we have x plus 1 here. If we cancel, we're left with log, and that's 1 over x minus 1. Now, remembering that 1 over x can be expressed as x to the minus 1. We should see that 1 over x minus 1 can be expressed as x minus 1 to the negative 1. So let's do that. So we're going to have log that's x minus 1 to the power negative 1. Now once we get to this stage, we should remember, again, laws of logs. Once we have a power, we can take that entire power and move it to the front of the class. Yeah? So that will give us negative 1 log x minus 1. Right? And since it's negative 1, we know that's just equal to negative log x minus 1. And we have moved from this expression up top to our answer being just that, negative log x minus 1. All right, so for this one, we also did this in class, but let me run through it quickly. Right, we know for the half, we can bring the half up as a power. So we can move it from the front of the class to be in the power that we're raising 9 to. But for the 1 is no logarithm, so we need to convert 1 to a log. How do we do that? We want to remember this basic principle of logs, right? This law of logarithms. Which is basically showing us that as long as the base and the end result are the same, then the result will always be 1. So in this case that we're doing, our base is 10. So as long as we keep the base as 10, then we're good. Right? Base is 10, so the end result must also be 10 for it to be 1. So we're saying so log I'm going to say 9 to the power 1 over 2 all of this plus 1. I would say 1 we can express as log. If we're using base 10, the end result must be 10 for the answer to be 1. Right? As long as the base is a, the end result must be a for the answer to be 1, for the power to be 1. Right? So log base 10 of 10 will always be 1. So we can replace 1 with log base 10 of 10. All right. So now we can continue. So we can see that 9 raised to the power half, which is the square root of 9, is just 3. Right, so we have log 3 plus 10. Now we have addition of 2 logs, same base. So we just multiply these end results. So we're going to say log of 3 times 10 which of course will be log 30. right? And that takes us to the end. So half log 9 plus 1 simplifies to be log 30. Let's look at another. Evaluate log to base 4 of 60. Now, on our calculators, we don't really have base 4. We have base 10, which is just log. So we want to convert this to base 10 in order to calculate. So we know the rule. Let me go back to the laws of logs. And here we have them. So converting or changing the base of a log. So I'm just going to copy this and bring it over to our question. Let's make this larger. Alright, so that's our reference. So if you notice, if we're converting to base C, we're going to have one log divided by another log. So in this case, we want to convert to base 10. Right? Because that's what we have on our calculators. So we're going to have log base 10 divided by log base 10. Right? Now in terms of what we are using, finding the log of, which one goes to the top? End result goes to the top, 60 over log 4, the base. And if you think about it logically, the base of a house is at the bottom. So if the base is 4, then we must divide by log 4. And then we can simply say on our calculators, log 60 divided by log 4 gives us, just a second, let me turn on my calculator. So log 60 divided by log 4, and I get 2.95 34. Yeah, 2.9534. So this is saying if we raise base 4 to the power 2.9534, we should basically get back 60. Right? I remember this is rounded, so it won't be exact, but let's try. If we say 4 raised to the power 2.9534, we should get something close to 60. So 4 raised to the power 2.9534 gives me 59.9962. Pretty close. In fact, if we round off the 2 decimal places here, it rounds off to 60. Alright, so that's one. Alright, here's another. So again, converting to base 10. So we're going to have log over log. The base is 3 and the base is at the bottom. So it's log 243 over base 3 over log 3. Alright, so calculators will say log 243 divided by log 3. And that gives me 5. So this is saying if we raise 5, right, if we raise base 3 to the power 5, we should get 243. So let's check. So base 3 raised to the power 5 gives me exactly 243. All right. So those are some log examples.